So let's do an example using then those oxidation numbers. Okay, so let's say we have zinc solid, set in solid, plus AuNO3, whoops, that's 3, both threes, 3 aqueous, and it's going to gold plus zinc NO3 2 aqueous. Okay? So write the unbalanced equation in ionic form. So write it dissociated. So zinc solid plus Au is going to be 3 positive aqueous. NO3 negative aqueous going to Au solid plus Zn2 positive aqueous plus NO3 negative aqueous. Okay? So then it says, and put in the oxidation numbers. So zinc solid will be 0. Gold is already, it's an ion, so it's 3 positive. This is an ion nitrate, it's negative. Gold is pure, so it's 0, 2 positive, and negative. So then you pick out your half reactions based on that. So you look and you say, okay, we have zinc 0 going to 2 positive. That's one of them. So set in solid going to Zn2 positive aqueous is going to be one of my half reactions. And the other one has to be Au3 positive aqueous going to Au solid. Okay? Then it says balance the atoms in the half reactions. 1, 1, 1, 1. Done. Add electrons to each half reaction to balance the charge. So I'll rewrite it down here since I left this room. So it'll be set in solid going to set in 2 positive aqueous. So where do I need to write the electrons here? I have to write them on the product side. Okay? And I have to put 2 in. Gold 3 positive aqueous going to Au solid. Have to add in 3, and I have to add them on the reactant side. So now they're balanced. Okay? Label the half reactions. This guy is losing electrons, so he's oxidation. And this one's gaining, he's reduction. Multiply the half reactions by the appropriate numbers. So there's 2 and 3, and we need to balance them. So the Zn dude is going to have to get multiplied by 3. And the gold is going to have to get multiplied by 2. And that way, whoops, this is not zinc, this is gold. That way our electrons will cancel out. Add the half reactions together, subtract the terms that show up on both sides. So in this case there isn't, but there might be some, like you might have a H positive ions on both sides or water on both sides. So you just reduce them so that you just have it on one side. So if there's 3 on one and 2 on the other, you end up with 1 on the side with the most. Okay, so then we're going to add them together. 3 set in solid plus 2 Au3 positive aqueous. Our little electrons are going to disappear. 3 set in 2 positive aqueous plus 2 Au solid. And then label the oxidizing and the reducing agents. This guy is going from 0 to 2 positive, so he's losing electrons, which means he's being oxidized, which means he's the reducing agent. This one's going from 3 positive to 0, so he's gaining electrons, which means he's being reduced, which means he's the oxidizing agent. So really it's the exact same steps that we were doing before. The only difference is now we're calling the zeros that we're putting up here the oxidation numbers. Okay, and I know the zeros are simple, but there'll be others that'll be a little more complicated. Okay, so now your homework, your practice questions.